Hey there, my friends. My name is Riaz, and welcome to this AWS Lambda and Serverless Computing course. Let's get started. This course is divided into several sections. We'll begin by building a simple Hello World example with API Gateway and AWS Lambda. And this should get you started with serverless computing. We'll first cover the basics of AWS serverless architecture, covering AWS Lambda, API Gateway, and DynamoDB. And then we'll dive deeper into these topics and cover the advanced concepts as well. We'll also learn building serverless workflow patterns using step functions, and then I'll teach you the best approach to building serverless applications, which is using frameworks like AWS SAM and the serverless framework. We'll take this further and I'll show you how to automate and streamline your serverless delivery and deployment with CI/CD tools like AWS Code Commit, Code Build, and Code Pipeline. We'll also learn some of the best practices of serverless computing and study different serverless architecture patterns. We'll not only study these serverless architecture patterns, we'll implement them as we build several end-to-end full stack projects. And I'm sure this course will give you enough practical experience to take on and tackle real-world serverless projects. I'll be using Node.js for all the demos in this course, and I have included a section on JavaScript and Node.js fundamentals at the end of this course. So, if you're new to Node.js, do go through that section before you begin with the next section. We'll also use JSON and YAML extensively in this course, and I have included an optional section on JSON and YAML fundamentals at the end of this course. So if you're new to JSON or YAML, do go through that section before you begin with the course starting from the next section. Alright, this course is available in the form of easy to follow videos. You can pause, rewind, or speed up each video to suit your needs so you can learn at a pace that's comfortable for you. And I'll be there if you ever have a question or need help. All the source code is also available for download inside the resources section. So before we go sprinting down the aisle and take it all in, I just wanted to take a moment and say thank you for being here. I'm so honored to be able to share my knowledge with you here today. I hope this journey is both fruitful and exciting for you. I enjoyed creating this course for you, and I hope you enjoy it too as you follow along. So let's get started in the next lecture. I'll see you there in just a few seconds. In the recent years, computing technology has been evolving at a phenomenal rate. Data storage has become very affordable and computing power has vastly increased. And this has allowed us to build applications that leverage these advancements in computing space. Cloud computing, for example, has made it possible for us to build cutting-edge applications at a fraction of a cost. Not just for big companies, but also for individual people. Public cloud providers like Amazon AWS, Microsoft Azure, Google Cloud Platform have removed the entry barriers and made computing very easy and affordable for common people. Having said that, the modern day applications demand high level of power, high level of compute power, as well as speed. For example, if your Facebook app doesn't show you what you need to see as soon as you open the Facebook app, most of you might simply close the app and move on. So the application has to be fast and responsive. And at the same time, it must be scalable with almost no downtime. Serverless computing is this new trend in cloud computing, which attempts to solve many of these challenges. Serverless computing will help you build next generation of systems that can handle demanding workloads and scale indefinitely without having to provision or manage any servers. Now, if you look at the traditional architecture, there are several activities and tasks that you must perform in order to run any particular application. First, you got to create and set up servers, install operating systems, install and set up databases, manage software patches and hardware updates, manage capacity and scaling, manage high availability through load balancing, and so on. And of course, this server infrastructure and the computing power has its own costs, which are often substantial. On the other hand, with serverless architecture, all these mundane tasks of managing the underlying infrastructure are abstracted away from us. So, in a way, when you use serverless architecture, you won't really feel like you're using any high end servers because you're not the one who is actually taking care of it. That's the reason this approach is called as serverless. That means serverless computing still uses servers, but you no longer have to worry about managing them or worry about the uptime, availability, or anything that has to do with the infrastructure part. With serverless, you kind of get to be more productive. You can completely focus on writing your code without having to worry about the underlying support system. So you simply upload your code to the cloud provider and it can run on demand as and when needed. With serverless, you write your code in the form of functions, just like you would write a function in any programming language. And these functions then run in the cloud. So you segregate your application logic into small independent functions or microservices and upload them to the cloud provider. These functions are stateless and can be invoked in response to different events. These events could be file uploads, database updates, in app activity, API calls, website clicks, sensor outputs, just like those from IoT devices, and so on. And all these can be accomplished without having to manage any infrastructure or having to size, provision, or scale a bunch of servers, and without having to worry about performance and availability. And this seriously allows us to laser focus on our application code and not get caught up in multitude of infrastructure issues. Now, to talk in a more technical terms, these serverless functions often run in Docker-like containers, and hence several instances of these functions can be run concurrently, like in a Docker swarm, for example, thus making them highly scalable. If you're new to these terms like Docker or container, nothing to worry. You really don't need to know about these terms to be able to build serverless applications. All this containerization happens behind the scenes and is completely taken care of by the cloud provider, in our case, AWS. Just for your information though, containers are a lightweight alternative to virtualization. They allow you to run your code in isolated, pre-configured environments. All this, however, is abstracted away from us when we build serverless applications in the AWS cloud. So, no need to break your head if this is new to you. In this course, we'll go over everything that you need to know to master serverless computing. So, please hang in there. You will have more clarity as we build our first serverless application in the next couple of minutes. So, in a nutshell, serverless means event-driven computing using small, independent, stateless functions running inside containers in the cloud. That's the short definition of what serverless is all about. So, you have your code running on the cloud platform, AWS in our case, and whenever the triggering event occurs, the cloud platform spins up a container or initializes a container, loads the function in it, and executes the function. And this happens almost instantaneously, thereby allowing us to build applications that respond quickly to new information and thus enhance the user experience. Once the function completes execution, it optionally returns a response back to the caller and then finally exits or shuts down. AWS provides a compute service called AWS Lambda, which essentially allows you to create and run serverless functions in the cloud. And in the very next lecture, I'm going to take you through a quick hands-on lab where we'll create a Hello World API using AWS Lambda and API Gateway. AWS Lambda and API Gateway are the two of the core services of the AWS serverless platform. So, if you're ready for a quick hands-on, let's jump in and get our hands dirty and we start learning by doing. In the next few lectures, we are going to create our first serverless API. In this hands-on lab, I'm going to introduce you to two key pieces of AWS serverless platform, AWS Lambda and API Gateway. So if you're ready, let's get started. Sign into your AWS console at aws.amazon.com. This is the AWS dashboard. The first service we'll look at is the Amazon API Gateway. Simply start typing API in the search box and you should be able to get to API Gateway. If you haven't created any APIs before in this account, this is the screen you're most likely to see. AWS does change its UI often, so you might see a different UI, but more or less it should provide you with a similar functionality. So let's get started. Here you'll find an option to create an API. We're going to create a new API manually. So let's choose new API option and give our API a name. Let's say we call it Hello World and hit the Create API button. Awesome. We'll now be presented with this resources screen where we create resources and methods for our API. Go to Actions and click on Create Resource. Let's call it Message, for example. And AWS will suggest a resource path or an API endpoint. This will be appended to our API's root URL. Hit the Create Resource button. Instead of the manual approach we are taking now, there are better ways of creating APIs with API Gateway. And I'll take you through each of those approaches later when we dive deeper into this. For now, let's get familiar with the API Gateway console. All right. Once we have our resource created, we'll add a method to it. A method is an HTTP verb like get, post, patch, delete, and so on. So from the Actions menu, choose Create Method. And here you can choose any of the HTTP verbs. I'm going to choose the get method here, so we can test our API directly from the browser. Select the get method and click the checkmark button. We have a couple of integration types here. We have Lambda function, HTTP, mock, AWS service, and VPC link. What I'm going to do right now is select a mock response. So we simply hardcode and return a dummy response from within the API Gateway. Click Save. This will take us to the method execution screen. It does sound a bit scary when you see the screen for the first time, but don't worry, it's easy when you understand the idea. When we make an API call, the incoming request is passed from the method request block to the integration request block, where we map or transform the incoming request to the format that our backend understands. In our case, there is no backend since we are simply mocking a response using the mock integration type. The response received from the backend is then mapped or transformed in the integration response block to match the format that the calling application expects. And then the method response relays the response back to the client. We'll get to the details of each of these later. For now, let's mock a response by returning a hard-coded JSON string. Click on integration response here and expand this response for HTTP 200 status. Then, under mapping templates, you'll find a template for application JSON content type. Click on that. And this is where we map the response returned by the backend to the response expected by the client application. So let's simply add a simple JSON string here. Let's say a key message with value hello world. Save that and we're done. We can now deploy this API so we can test it from the browser. So from the Actions menu, choose Deploy API. We have to create a deployment stage here. So we can have different stages for deployment, testing, and production pipelines, for example. So choose a new stage and give it a name. Let's say test and click deploy. So now we are on the stages screen and our API has an invoke URL to call the API. And the URL also includes the name of our deployment stage. Let's click on this URL to open it in a new tab. It says missing authentication token. This is because this is the root of the API and there is no get method at the API root. Our get method is at the /message endpoint. So if you go to the resources section and look at the methods, you will see that our endpoint is at /message. So let's copy the endpoint path and we'll paste it right after the API root here. Hit enter. And there we go. We see hello world printed at the output. Amazing. We can also test this method from the method execution screen right here by clicking this test button. We don't have any path or query parameters for this method. Simply click the test button and we should see hello world here as well. Awesome. That was fairly easy, right? We created an API endpoint with a few clicks on the API Gateway console. And since it was a get method, we could also see the response directly in the browser. This was a very simple example. What we basically did here is we mocked a response within the API Gateway, and more importantly, this was accomplished without setting up any servers, meaning it's a serverless API. And the intention of this lab was to give you a feel of the API Gateway console. In the next lecture, we'll make this API a little more dynamic by replacing this mock response with a serverless function using AWS Lambda. So let's continue to the next lecture. In this lecture, we're going to create a serverless function or a Lambda function and hook it up with the API we created in the last lecture. This will allow us to return a dynamic message instead of simply hard coding a hello world string. So let's get started. On the AWS dashboard, from the services menu, I'm going to select Lambda from under compute and open it in a new tab. Click on create function to create a new serverless function. We can author it from scratch or use a blueprint as a starting point, or we can also choose a function from the serverless application repository. This is the repository of serverless apps created by the AWS developer community. We're going to author the function from scratch, so we keep the author from scratch option selected. Let's name our function, say get random message. And for the runtime, we can use any of these runtimes. We're going to use the Node.js for all the demos in this course. Node 6.10 has been selected by default here. We can also use Node 8.10. Let's use the default 6.10 for now, and in the next video I'll show you how to use the Node 8.10 runtime as well. Then for role, we can choose an existing role, or we can create a new role either from templates, or we can create a custom role ourselves. We're going to create a custom role. So choose create a custom role option from the drop-down, and this will take us to the IAM, Identity and Access Management. We can either accept the default role name or change it. I'm going to change it slightly, just in case I have an existing role with the same name. So I'll add underscore role at the end, for example. If we click on the View Policy Document option, we should be able to see the role policy here. This policy simply grants access to CloudWatch logs, so our Lambda function can write logs to the AWS CloudWatch service. So click on Allow, and that's it. The role has been added to our Lambda function. Click on Create Function button to continue. Our function is ready now, and you can see that it has access to Amazon CloudWatch logs. If you scroll down, you can see the function code. It's using the Node 6.10 runtime, and handler is index.handler. Index.handler simply means a function named handler defined within the index.js file. So it's fairly straightforward. The event argument receives the incoming data from the triggering event. The context object sets the context of the function from the execution environment. Callback is the callback function that returns the response back to the caller. We'll look into the specifics of these arguments a little later. For now, we don't need either of these. So we'll create an array of few messages and return a random message as the function response. So let's declare an array variable called messages, and inside it I'll add a few message strings. Let's say hello world, hello serverless, and I'm going to paste in some more strings that I already have with me just to save some time. And then inside the handler function, we'll pick a random string from this messages array. So let's say let message equal to messages array. And inside it, we can use math.random. Math.random is going to give us a random number from 0 to 1, excluding 1, of course. So we multiply that by 10 to get a random number between 0 to 10. And as you can see, we have about 10 messages here. So we're trying to get a random number between 0 to 10, excluding 10, of course. And then we'll use math.floor to convert this number into an integer. So now that we have a random message, we simply return it back via the callback. So we can remove this part, the HTTP response part here, and simply return the message variable via the callback. Just like that. That's about it. Save the function, It's a pretty simple function, good enough for us to get a hang of AWS Lambda. To test this function, click on Test button. We know that serverless functions are event-driven, so we'll need to configure a test event. Our function doesn't expect any input data, so we simply create an empty event to test it. Name the event, let's say empty event data. All right, click create. And now we should be able to test this function. Click the test button once again. And we have a success response. Let's expand it. Doing everything I love. Awesome. If we test it again, it's going to return some other string. Yay, I'm learning something new today. And yes, indeed we learned to build serverless stuff today. Amazing. You'll see the log output here. And you'll be able to see the same log output if you click on this logs link. It will take us to the CloudWatch console where these logs are stored. Let's click the latest one, and it's going to show us basically when the function started, when it ended, and some other information like how long this function ran, what was the build duration, and so on. Now we can hook this Lambda function to our API in the API gateway to make our function return this dynamic message. Why don't we do that in the very next lecture? So let's continue to the next lecture, and I'll see you there in just a bit. Now that we have our Lambda function ready, let's go to API Gateway console and hook this function to our API. Let's open the get method. We changed the integration type from mock to Lambda function. So click on integration request. Change the integration type from mock to Lambda function. My Lambda function is in the region US-US2. So if you look at the Lambda console, you'll find the region code in the URL here. All right, then we simply start typing the name of our Lambda function. That is get random message, and that shows up here. And click on save. It will ask us to confirm that we want to switch to Lambda integration. Because we're changing the integration type from mock to Lambda, it's going to ask us. Click OK to confirm. And now it's going to ask to give permissions to API Gateway to invoke our Lambda function. Click OK, and AWS will automatically assign the necessary permissions to the API Gateway service to invoke our Lambda function. Let's go back to the method execution screen so we can test this new API. Click test. There are no parameters for this method, so simply click the test button. And we can see the response body. Over the moon. But now the response we see is slightly different from what we had earlier with the mock integration. It's a plain text string, and if you see the response from our earlier test, we see a JSON string or a JSON object with key message and a corresponding value. So we have to actually convert this Lambda response to JSON format. So let's go back in here and click on integration response. Expand the HTTP 200 status response. And under mapping templates, select application JSON content type. Here we have to specify the transformation rules to map the incoming data to the expected JSON format. We create a simple JSON string here, just like we did in the last lecture. We add a key called message, And in the value, instead of hard coding, we pass the body of the Lambda response, the response we received from the Lambda function. We can access the Lambda response body using $input.body. Just like that. $input is a predefined variable, and we'll discuss more on this a little later in the course. For now, just save this. And back to the method execution screen. Let's test it locally first before we deploy the API. Click on Test. And we have the JSON response. Wow. But we see the double quotes appearing twice here. So to correct that, let's go back once again to integration response. And we can just remove these quotes here. Save, and let's try it again. Click on Test, and there we go. Hello serverless. Click it again, and it should show some other message. Wow, it's a great day today. And indeed it is, right? Amazing. Now, before we can test this in the browser, we have to redeploy our API. So once you've completed testing locally, we can choose Deploy API from the Actions menu. Select a stage and deploy. And now our API has been deployed. This is the API root URL, and we have to append it with our resource endpoint, that is /message. So if we refresh this page, we should see a new response every time. And we can see a different message as we refresh the browser. World at my feet. Over the moon. Amazing. I hope you're over the moon as well. So I hope this quick hands-on on AWS Lambda and API Gateway has you pumped up and excited and made you interested to learn even more about this amazing world of serverless computing. And if it has, let's continue further and we'll dig into this even deeper. So thank you for joining me here, and I'll see you in the next lecture in just a few seconds. We used the Node.js 6.10 runtime in the last lecture. So I'm going to quickly show you the same example using Node.js 8.10 runtime. So inside the Lambda function, we simply switch the runtime from 6.10 to 8.10. Save the function, and it's still going to work because this JavaScript code is valid in Node.js 8.10 as well. So let's test it out. And we can see that it's working well. And if you wanted to use the async await feature that's supported by this new Node.js 8.10 runtime, you can do that as well. So what I'm going to do is simply add async here before the function definition. And in that case, we won't have a callback, so we remove the callback. And inside the function, instead of the callback, we simply return the message. Just like that. We don't need to await anything here, so I'm not going to use the await operator. So save the function and let's test it out. And it's working fine, so it's still a great day today. And if we go back to our API in the browser and test it, it's going to work. We don't have to redeploy the API in this case because we did not change anything in the API gateway. So refresh this page. and we can see that is still working. Just to demonstrate that the API is actually showing the response from our new Lambda function running on 8.10, let's go back to the Lambda console and change our message string slightly. So what I'm going to do is simply add an extra exclamation mark to each of these message strings. Save the function. And now if we refresh the browser, we should see messages with 2 exclamation marks. And it's working as expected. So it's still a great day today. Awesome. So thank you for your time, and in the next lecture, we look at some key features along with some pros and cons of serverless architecture. Now let's talk a little more on the pros and cons of serverless computing. First, as we discussed, there are no servers or operating systems or hardware or software to maintain. And that makes our life as a developer or DevOps so much easier. So kind of more me time for you, and you can be more productive and be able to laser focus on creating stunning applications. So serverless is all about faster innovation, high productivity, and faster time to market. And in most cases, serverless applications require little to no administration. All right, the next benefit is easy and efficient scaling. Serverless applications can be scaled automatically or at the most with a few clicks to choose your desired capacity. And there is no need to create any specialized scalable architecture or designs. You can get a large number of serverless functions running within seconds, and each function runs for a few hundred milliseconds to a few minutes. And you can allocate resources for each of these functions individually. And this is going to allow us to scale our application easily and at the same time efficiently. Thirdly, serverless approach provides built-in high availability and fault tolerance. You don't need to have any specialized infrastructure to make your applications highly available or fault tolerant. All your applications get this benefit of availability and fault tolerance by default, irrespective of whether you're just building a Hello World app for your testing or you're building the next Facebook or YouTube. Service integration is another benefit. AWS provides a host of services that readily integrate with each other, and this is something that's going to allow you to perform a lot of stuff very, very easily. For example, you could be sending text notifications, emails, running analytics, hosting APIs, storing files, running automated workflows, deploying machine learning models, and so on. And all this can integrate seamlessly with your serverless application. Then the real benefit of serverless is that there is no idle capacity. You pay only for what you use and no more. For example, with traditional architecture, say you created a server with 100 gigs of memory and you are only using about 10 gigs of it. You'll still have to pay for the 90 gigs you never used. But with the serverless architecture, you only pay for what you use. If you use 10 gigs, you only pay for those 10 gigs. Also, with AWS Lambda, which is the core component of Amazon's serverless platform, you pay only for the time your code runs. So there is no charge if your code is not running. If your code runs for say 100 milliseconds, then you're charged only for that 100 milliseconds and no more. And that's really a very fine-grained control, and certainly this results in a substantial cost savings for your business. Even with all these benefits, serverless may not be the solution for all your problems. It's not a silver bullet and does come with some challenges, not many though. The first one is vendor lock-ins. So there are a handful of cloud providers like Amazon AWS, Microsoft Azure, Google Cloud Platform, IBM Cloud, and there are some more. And they really want you to use more and more of their services, of course, for obvious reasons. And they want to build an ecosystem of related services that work together. This may not be really a deal breaker though, and we'll discuss what is called as multi-provider serverless later in the course as a way to alleviate this challenge. Another concern with serverless is the public cloud. The serverless architectures run on the public cloud. So some use cases or industry-specific regulatory requirements may be a deterrent to using this public cloud. So these cases might be very few, but then again, if your use case lies in this category, then serverless may not be a good fit. Having said that, serverless can be run on private clouds as well. So you could still leverage serverless in such cases. However, we're not going to get into that discussion here. Let's just focus on AWS serverless platform for our purpose here. Another point to keep in mind is the level of control. So essentially, you're giving up some degree of control by letting someone else manage the infrastructure for you. And in some situations wherein you need more control of the hardware resources or of the OS level resources, this might prove to be a limitation. The core component of AWS serverless architecture is the compute service called AWS Lambda. Lambda lets you run your serverless functions in the AWS cloud. AWS Lambda was launched back in 2014, and that's when the idea of serverless was born. The other players quickly followed suit, and with growing use of social media, streaming data, and Internet of Things devices, the relevance of serverless computing is rising very, very rapidly. AWS Lambda is still the market leader in the serverless space. If you look at this Google Trends graph comparing the major players in serverless space, you will see that Lambda has been growing consistently and at a much faster pace than the other players. Although Lambda itself is fairly new, having launched just a few years back, the other players like Microsoft Azure, Google Cloud Functions, IBM Cloud Functions are even newer. Similarly, AWS as a cloud provider is still preferred highly as compared to other players like Microsoft Azure, Google Cloud Platform, and the IBM Cloud. Besides being the first to enter the serverless space, AWS Lambda has its strength being part of the huge AWS ecosystem, thereby allowing seamless integration with a host of other AWS services. In this course, we're going to mainly focus on the serverless offerings provided by the AWS platform. So in the next lecture, let's look at the core services in the AWS ecosystem that form the foundation of this serverless platform on AWS. And we'll also talk about some additional AWS services that are popularly used along with the core services in the AWS serverless space. As part of its serverless platform, AWS provides a set of web services that you can use to build and run your serverless applications. So in this lecture, let me give you a quick overview of different AWS services that form the AWS serverless platform. All these services are fully managed, meaning you can focus on your core application logic and AWS does the rest for you. There are three core services that you can find in almost every serverless application. And these are AWS Lambda, Amazon API Gateway, and AWS DynamoDB. These services are the foundation or the backbone of the AWS serverless platform, so to say. And then there are additional web services that you can use in serverless applications depending on your use case. And these could be Amazon S3, SNS, SQS, AWS Step Functions, Kinesis, Athena, and so on. So let's go over these services briefly, and then we'll discuss the common use cases of the serverless architecture as well. When it comes to serverless applications, AWS Lambda is the most important service that you will need in your serverless applications. AWS Lambda lets you run your code without having to create or manage any servers. You simply upload your code to Lambda, and Lambda does the rest for you and ensures that your code runs on highly scalable and highly available infrastructure. Each piece of code that you upload to Lambda is called as a Lambda function, and it runs in an independent, isolated environment, also called as a container. As discussed earlier, with Lambda, you only pay for the time your code runs, and there is no charge when your code is not running. Lambda provides fine-grained access control, letting you decide who can invoke the Lambda functions and which services can be executed by the Lambda functions. Lambda also comes with version management capabilities, allowing you to manage your deployments efficiently. Second service is Amazon API Gateway. API Gateway, as the name indicates, helps you create and publish APIs, and it tightly integrates with AWS Lambda to let you create completely serverless APIs. Again, this is a fully managed service, and you can use it to build RESTful APIs. RESTful APIs are the APIs that follow a client-server model where client is stateful and the server is completely stateless. These APIs can then be consumed by your web or mobile applications, allowing you to interact with different AWS services through your code running on Lambda. API Gateway can handle thousands of concurrent API calls and also gives you full control to create your APIs with fine-grained access control and version management capabilities. The third service of the serverless platform is Amazon DynamoDB. DynamoDB is highly scalable, high-performance, NoSQL serverless database. DynamoDB can scale on demand to support virtually unlimited concurrent read-write operations with response times in single-digit milliseconds. And then you have DynamoDB DAX, or DynamoDB Accelerator, which further can bring down the response times from milliseconds to microseconds. DAX is a caching service that is provided by Amazon on top of Amazon DynamoDB. AWS Lambda, API Gateway, and DynamoDB are the three most commonly used services in serverless applications, and we'll dive deeper into all three of these services in the upcoming sections of this course. Now, depending on your use cases, you might need other services as well. So let's look at these additional services right in the next lecture. Amazon Simple Storage Service, or S3, is a very simple and intuitive web service that you can use to store and access your data from anywhere on the web and with fine-grained access control. S3 also lets you build static websites that can interact with your Lambda code, so you can really use S3 as a front end of your serverless applications. With serverless applications, since there are no servers, you need a reliable way for different web services or different software components to talk to each other or communicate with each other. And AWS provides two services that you can use here for in-process messaging, SNS and SQS. SNS, or Simple Notification Service, is a fully managed notification service that allows you to publish notifications, and any services or software components that subscribe to these notifications will receive the messages. Second service is SQS, or Simple Queue Service. This is a very simple and intuitive messaging service that you can use to send and receive messages at virtually any volume. SQS allows multiple publishers and consumers to read and write messages from the same queue, and it can retain these messages up to a certain predefined time period or until you explicitly delete the message. And then in any serverless application, there could be several Lambda functions working together, and your application might need a way to orchestrate these functions. That is, execute them in a specific order or depending on certain logic or certain conditions that might be known at the runtime. So AWS Step Functions is a service that helps you with this orchestration. AWS Step Functions let you build visual workflows to coordinate different Lambda functions to work together and form a larger serverless application. Then coming to analytics, Amazon provides two web services, Amazon Kinesis and Amazon Athena. Kinesis is a platform for streaming data applications. And if your application requires you to work with or analyze streaming data in real time, you may want to use Amazon Kinesis. Amazon Athena is an interactive query service that you can use to query your data stored in Amazon S3 using standard SQL syntax. You also have debugging tools like AWS X-Ray and debugging and logging tools like AWS CloudWatch. Then we have AWS Cognito, which is serverless user authentication and management service. It supports authentication of users for your application via username and passwords, and also via federated identity or OpenID providers like Facebook, Google, Twitter, Amazon, and so on. And you can also have your own custom OpenID providers. So we discussed some of the many AWS services that we can use with our serverless applications, and we'll explore these services throughout this course. AWS also provides you with fully functional SDKs that you can use to build your serverless applications. AWS Lambda supports several programming languages like Node.js or JavaScript, Python, Java, C#, .NET Core, and also Google Go. Throughout this course, we'll build several demos and learn how to make use of these services within our serverless applications. In the next lecture, let's go over some of the prominent use cases for the serverless architecture. Let's look at some of the use cases for serverless applications. The serverless architecture allows us to build just about any type of application or backend service that you can think of. Let's go over some of the most common use cases where you can use serverless architecture. The first and the most prominent one is application backends. Serverless allows you to build backends for web, mobile, or even IoT applications. And later in this course, we'll build all these three types of backends together with hands-on. Serverless web applications and their backends typically make use of AWS Lambda, API Gateway, DynamoDB, S3, or even step functions as needed. End users might interact with your applications through web, mobile smartphones, or even IoT devices. And these front ends act as event sources to trigger our Lambda code. Each incoming request from the end user is typically received by one of the endpoints exposed by API Gateway. API Gateway then triggers a call to Lambda function, and Lambda function then coordinates with different web services like S3, DynamoDB to generate a response, and then returns that response back to the end user, possibly through the same channel like API Gateway. Amazon S3 can also be used to create the app front ends in this case. These front ends are wired to the serverless backends by means of the APIs that we create using the API Gateway. Such applications could have very unpredictable usage patterns with, for example, periods of extremely high user traffic followed by minimal to no traffic, and your application must be geared to handle these spikes in traffic without the need for any expensive infrastructure. With AWS Lambda, your applications can scale on demand and you pay only for what you use. And in most cases, such serverless applications require almost zero administration. Another use case for serverless architecture is real-time data processing systems or streaming data processing systems. You can use Amazon Kinesis or Kinesis Firehose with Lambda, DynamoDB, and S3 to create your real-time data processing systems. These systems typically have variable workloads, and serverless approach helps here by helping with the automatic scaling during high workloads and then scaling down and saving costs during the idle time. Amazon Kinesis is a service that lets you collect, process, and analyze real-time streaming data from multiple sources at absolutely any scale. And you can literally process terabytes of data every hour coming in from thousands and thousands of sources simultaneously. For example, social media streaming data from several sources can be loaded into Kinesis simultaneously and then processed in real time using AWS Lambda and DynamoDB. Kinesis also provides data analytics services that can be used to build real-time analytics applications. And later in this course, we go through the hands-on demos where we'll process streaming data from Kinesis as well as from DynamoDB streams using AWS Lambda. Automation and continuous delivery are even more crucial when building serverless applications. These tools make your life as a developer or as DevOps so much easier. A typical serverless application would have many Lambda functions and a number of APIs or API endpoints, and configuring each of them manually, maintaining their versions, and following a uniform development process or deployment process manually is not a great idea. It's time consuming and, of course, prone to errors. Automating these tasks fully or at least partly will make your application lifecycle easier and manageable in the long run. Ideally, you should be able to maintain a code base in a source control system or version control system, run tests, and deploy your application automatically. The only time you should deploy Lambda functions manually or configure API Gateway using the web console is while you learn. Once you begin working on real serverless applications, you should have a well-defined deployment process, and ideally, it should be automated. There are several tools that play an important role here, and we'll quickly go through these in this lecture, and later in the course, we'll learn how to use these tools as well. There are two frameworks that help you work with your serverless applications efficiently: the AWS SAM and the serverless framework. AWS SAM, or the Serverless Application Model, is a tool provided by AWS, while the serverless framework is a popular third-party tool provided by a company named Serverless Inc. First, let's talk about the AWS SAM, or the Serverless Application Model. SAM is a lightweight version of AWS CloudFormation. CloudFormation is a service that allows you to automate creating and deploying various AWS services quickly using a text-based template file. AWS SAM uses similar template file but with a simplified syntax, more suited for serverless applications. CloudFormation internally converts this SAM template into the standard CloudFormation syntax to create and deploy our serverless resources. We'll dive deeper into SAM and learn how to use it later in this course. Now let's discuss the alternative third-party framework called the Serverless Framework. This is an open source tool and works on a similar lines as the AWS SAM. The template syntax it uses, however, is slightly different but equally easy. The serverless framework is quite a popular tool and many organizations are using it for their application deployments. The serverless framework also has an open source plugin system which allows anyone to extend its functionality. And hence it provides rich features apart from just being able to deploy serverless resources. We'll learn how to use the serverless framework later in the course. Irrespective of which framework you use, continuous integration or continuous delivery is something you should consider using in order to automate your application deployment process. AWS provides a host of tools for this purpose. AWS Code Commit is a version control or source control system that provides a Git-based repository, and you can use it as your code base. This allows you to maintain private repositories of your application code. And as of recording this video, the AWS free tier provides you with unlimited private repositories with about 50 GB of storage and 10,000 Git requests per month for up to, I believe, 5 users at no cost to you. Then we have AWS Code Build, which allows you to build your serverless code and create or update AWS resources automatically via CloudFormation. This allows you to deploy your serverless applications as well. AWS Code Pipeline then is a service that allows you to define the delivery or deployment cycle from source repository through deployment and automate the application deployment process or the application deployment pipeline. Later in the course, we'll learn how to use these tools together to automate the deployment process for our serverless applications. That's all for this lecture. In the next lecture, let's get our development environment set up. So we are ready for hands-on practice as we dive deeper into serverless computing with AWS. So thank you for your time, and I'll see you in the next lecture in just a few seconds. In this video, we'll create and set up a new AWS user to access AWS. This will allow us to connect to AWS resources from our local computer. We'll also install AWS CLI tools so we can connect to AWS using the command line or the terminal. If you're going to practice the examples presented in this course with me, then please do follow along with this video and have your local environment set up before we dive into hands-on sessions. To get started, you'll need access to an AWS account. I'm assuming that you did the last Hello World example with me, and so you already have an AWS account. However, if you still do not have one, this is the time to sign up for a free AWS account on the AWS website at aws.amazon.com. You can also log into AWS using your amazon.com retail account. So pause this video here and grab your AWS account details. Once you have them with you, sign into the AWS console at aws.amazon.com and we'll continue from there. Alright, I hope you're logged into your AWS account now. So let's set up a new AWS user. It's fairly simple to do that. From the AWS console, search for IAM and open it. Go to Users page and click on Add User. Let's name the user as Serverless Admin. You can name it whatever you like, but since we're going to use this user later on with the serverless framework to deploy our applications, naming it as Serverless Admin might make it easy for us to remember that this is a framework user. And since we'll use this user to connect to AWS from our applications, we only need to provide this user with programmatic access. AWS console access is not required since we'll not be logging into AWS console with this user. But if you want to log into AWS console with this user, then you may want to enable this console access as well. I'm going to leave it unchecked though. When you choose only the programmatic access, AWS will not create any password for this user and will only create a set of API credentials, that is an access key and a secret key. Click Next. Now we need to tell AWS what permissions this user would require. Click on Attach Existing Policies directly. Search for and select Administrator Access. This is going to provide this user full access to your AWS account. Ideally, we may not want to do this, but the serverless framework is kind of permission hungry and requires a lot of permissions for the framework user. So while we're learning, it's best to use administrator access so we can focus on learning. So be sure to keep the credentials for this user in a safe place. Click Next and review if everything looks fine. And then click Create User button to create this user. AWS will show us the API credentials. Copy or download them to your local computer and keep them in a safe place. There are several ways to set up these credentials on our computer. We're going to simply add them to our environment variables on our computer. I'm using Windows 10 for this course. Steps to set up the environment variables on Mac or Linux are slightly different, and I'll come to it in a bit. If you're on Windows, preferably log in with administrator access and then from the Start menu, search for Environment Variables and choose to edit environment variables for your account. Then under User Variables, click New. Add API credentials we downloaded as key value pairs here. So let's add AWS Access Key ID as the key and our actual access key for the user we just created as its value. Similarly, we'll also add AWS Secret Access Key as key and our actual secret key for this user as its value. It's also a good idea to set up a default region. So let's add one more environment variable, AWS default region, and set this up with value for the default AWS region that you're using. I'll be using US West 2, and you could use the same or any region that's closest to you. You can choose a suitable region from the top right corner of your AWS Management Console. You could also do the same thing via the command prompt or PowerShell by using the set command as shown here. Let's continue to the next lecture. If you're using Mac or Unix, before we continue, in this lecture, I'm going to show you how to set up the environment variables on your computer. If you're using Windows, you can skip over to the next lecture. So open the terminal on your Mac or Unix computer, and here we simply export the environment variables using the export command. So we could say export AWS access key ID equal to the actual access key for the user we created. Then we also add AWS secret access key as key with its value in a similar fashion. It's also a good idea to set up a default region. So we add one more environment variable, AWS default region, and set this up with the value for the default AWS region. I'll be using US West 2, and you could use the same or use the AWS region that's closest to you. You can find the region code from the URL of your AWS Management Console as we saw in the last lecture. This export command, however, will store the environment variables in your current profile temporarily. To store them permanently, you can also add them manually to your profile. The default shell on Mac is Bash shell unless you have changed it manually. Set an environment variable permanently by placing these export commands in your Bash shell startup script .bashrc or .bash profile or .profile of your home directory, or /etc/profile for system-wide operations. Note that files beginning with dot are hidden by default. To display hidden files, use command ls-a or ls-al. So you can edit or create .bash profile file and add the export commands in that file. Let's do that. We can say nano followed by the path to the bash profile ~bash_profile and hit enter. Simply paste in the 3 export commands at the end of this file. Save and exit using Ctrl+O, Y followed by enter. That's about it. This will store them permanently. Let's continue to the next lecture. In this lecture, we'll install the AWS CLI or the command line tool to work with AWS from the command line or from the terminal. I'm assuming that you've created an IAM user, downloaded the credentials, and have set up the environment variables. If not, please review the previous video. Specifically, you should have added the AWS access key ID, AWS secret access key, and the default region to your environment variables. All right, let's continue. We can simply Google for AWS CLI install, and we should be able to find the page. I'm also putting a direct link in the resources section of this video, so you can use it to go to the download page. Use the left sidebar to locate the installable for your operating system. I'm using Windows, so I'll locate it here. If you're on Mac or Linux, you can use the appropriate link. The easiest way for Mac or Linux OS is to use the bundled installer using the link here. I'm on Windows, so I'm going to find the installation package on the Windows link. If you scroll down, you'll find upgraded MSI installers, and these use the latest version of Python. You can download the appropriate version. I'm on 64-bit machine, so I'll use the first link. If you're not sure whether you have a 64 or 32-bit machine, simply download the installer from this third link and it would automatically detect the type of machine you have. So let's download and run this install and we should be good to go. If you're on Windows, you can use the command prompt or PowerShell, and on Mac and Linux, you will use the terminal to run the CLI commands. An AWS CLI command always starts with AWS followed by the name of the service and then the name of the action that we intend to perform. And after that, we specify additional options relevant to the requested action. For example, if we say AWS help and hit enter, it would give us the syntax documentation for using this CLI. You can scroll down using the enter key and use Ctrl+C to exit. Similarly, if we say AWS Lambda help and hit enter, we would get the documentation for using CLI with the AWS Lambda service. You can find the same documentation over the web as well. Simply Google for AWS Lambda CLI commands, and the first results should take you to the appropriate page. I have also added the link to this documentation in the resources section of this video, so you can open it directly as well. That's about it. In the next lecture, we'll install Node.js, VS Code, and Postman. I'll be using Node.js for all the demos in this course, so I'll show you how to install Node.js on your computer. And optionally, you can also install an IDE or integrated development environment of your choice to write your code. I'll be using the IDE that I like, which is VS Code, and if you'd like to use it as well, I'll show you how to install it. Many of our demos will include HTTP or REST APIs, so you'll need some kind of API testing tool. You can use any tool of your choice. I like using Postman tools, so if you'd like to use it as well, I'll show you how to install it. If you're familiar with these tabs or have these tools already installed, you can skip over to the next lecture. Alright, let's install Node.js. If you're on Mac or Linux, open the terminal, or on Windows, open the command prompt or PowerShell. First, let's find out if you have Node on your machine or not. So run node space -- version. You can see that on this machine I'm running Node version 8.11.1. On your machine, you may or may not have Node installed, or you might have a different version. Either way, I want you to install the latest version of Node. So open up your browser and head over to nodejs.org. On this page, you can see we have two versions of Node. One is the latest stable version, LTS version 8.11.4, which is recommended for most users at the time of recording this video. And there's always a newer version which is experimental and it might not be stable. So I want you to install the latest stable version that you see in your browser. The latest version might change in future, however, the installation steps would mostly remain the same. So let's go ahead, download the LTS version for your operating system, and run the installer. Simply follow the prompts and your installation will be done. Once done, go back to the command prompt or terminal and let's run node-version one more time. And you can see that I upgraded my node to version 8.11.4. Now let's install an IDE if you don't have one already. You can use any IDE of your choice, or you can as well use any simple text editor like Notepad, Notepad++, Sublime, or the likes. I prefer using VS Code, and this is available across platforms. So if you'd like to use VS Code as well, go to code.visualstudio.com in your browser, and here download the installer for your operating system. Run the installer and follow the prompts. The installation should be straightforward. Optionally, you can check the options to enable Open with Code context menu and associate related files with VS Code. I like to have them all checked. Continue with the setup and you should be all set. We also need a tool to test our APIs, so we're going to install Postman app. You can also install the Postman Chrome extension if you like. So head over to getpostman.com/apps and download the installer and run it. And the installation should be straightforward. That's about it. Let's test the setup in the very next video. Now let's test the setup to make sure we have done everything correctly. Open VS Code or launch command prompt or the terminal if you're using any other IDE. To open the terminal from within VS Code, simply run Ctrl backtick and run node-version. You should see the node version that we just installed. Now let's test if we can connect to AWS from our machine. From the terminal, type AWS STS get-caller-identity, just like that, and hit enter. And this should display information about the AWS serverless admin user that we created and added to the environment variables. If it does, that means we have configured the environment variables correctly. If you see an error, that means environment variables were not set up or were set up incorrectly and you have to set them up again. So if you're seeing any errors, now we have our development environment ready, and we also have a fair idea of what we are going to learn in this course. Before we continue further, in this lecture, I'll share my recommended approach to taking this course so you can get the best value from it. First off, you should watch the videos, and if something is not clear or apparent at first, feel free to watch that video again. And if you find that I'm going too fast or too slow, this video player also has a playback speed control. Make use of that and adjust the speed to your liking. So if you find my pace too slow, you can speed me up by up to 2 times. And if you find that I'm going too fast, you can slow me down as well using the same playback speed control. I also highly encourage you to code along or build along with me. Do write the code, try out the demos, test out the examples that I show you, and this will only help solidify your understanding of the ideas and concepts more effectively than simply watching the videos. Also, be mindful of AWS pricing if you're experimenting a lot. However, overall, most of the demos that I show you in this course will be well within the free tier, but a subset of them may not be free. So do check the current pricing on the AWS website. And occasionally there could be times when you need help or need more information. And to help you out in these situations, I provide some resources like source code files, solutions, as well as additional reference links. You'll find these attached to various lectures, and you can certainly download these and compare my solution with yours. And if you still are stuck or have some other queries or questions related to the course, please do not hesitate to ask them. Ask in the Q&A section, and I'm always here to help you and to guide you. Also, help other students if you can. Participate in the Q&A section, open up new discussions, and get the ball rolling. That's about it. There are some background topics, specifically JSON, YAML, Node.js, JavaScript, and you may want to review them before we dive into the main serverless topics. I have created 2 optional sections for those of you who are new to these topics. These optional sections are included at the end of this course. If you're already familiar with these topics, feel free to skip them. If you're new to these topics though, then I highly recommend going through those optional sections before you start with the next section. These optional sections, as I said, are available at the end of this course. All right. And I really hope you're enjoying these videos. I really hope you're learning a lot. And if you are, then I just quickly kind of throw it out there. It would mean a great deal to me if you just take a minute or two to leave a positive feedback. And it makes a huge impact on what we are doing here, my ability to continue being successful teaching and developing these courses for you. And it would mean a lot. So that's all for right now. And let's finally dive in and get the ball rolling.